So I just heard a hilarious joke about energy. You guys interested in hearing it? Absolutely not. Oh, okay. Then let's just go right into it. This movie will be discussing the principles of energy, talking about how the energy from the sun, when it hits the earth, what happens to it. Well, some of that energy hits the earth, much like is being shown in this image, and then it just bounces right off, right back into outer space. But this clearly does not happen with 100% of the sun's energy, because if all that energy coming from the sun just hit the earth and reflected right back into outer space, so all of this energy just bounced right back into outer space, then there would be no heat on our planet, at least the surface of our planet. And that would have caused the oceans, the lakes, the rivers, everything to freeze. And our Earth would have a tremendous resemblance of a giant celestial ice cube. So truly, rather than all that energy just hitting the Earth and bouncing right back into outer space, some of that is actually absorbed by our atmosphere. So not all of it just reflects back in outer space, clearly, since the world is much, much warmer than it otherwise would be. Some of that energy is actually caught by our atmosphere, and it heats up our atmosphere, and it keeps our planet warm, much like a blanket or a coat would keep you warm. So why do you think that this arrow here is so big when it comes off the sun, and then the amount bouncing off the earth, that arrow representing the energy from the sun, is smaller? So this arrow is way bigger than this arrow, and I did that on purpose. Why do you think so? Well, hopefully you're thinking it's because not all of this energy represented by this arrow is being reflected into outer space. Some of this arrow is actually absorbed by the Earth, like I had previously said a second ago. And you're familiar with this absorption of the sun's energy because, as you know, when standing outside on a sunny day, not all of the sun's energy is being reflected out into outer space, and clearly some of that is not being absorbed by the atmosphere. Some of the energy from the sun is actually absorbed by the organisms living on the surface, and some actually is absorbed by the Earth itself, the surface of the Earth itself, the continents, and also the oceans. But a question does arise. So where does the energy go after it hits you and after you absorb it? Where does the energy from the sun go after you absorb it or the surface of the earth absorbs it? Is it trapped inside of you forever? And the answer is no. At some point, that energy that hit you, that was absorbed by your body, is then released back into the air around you. So another way of describing this would be to say that the sun's energy is released by you back into the atmosphere around you. And it is quite probable that the sun's energy that hit you, that you then release into the air, might actually make its way back out into outer space at some point. So the energy that came from the sun, from outer space, will return to outer space. But there are some organisms on this planet that are extremely special, and we rely on heavily to do something with that energy. Besides just absorb it and let it go, they can actually do something with that energy from the sun. They can actually store it. Plants. Plants can actually absorb the sun's energy and create these molecules called sugar that store that energy. So for the rest of this little video, I want you to take a look at this diagram I have. And this is going to be the basis of the diagram for the rest of this video. Right here we have the arrow showing the flow of the sun's energy. So the arrows represent the amount of the sun's energy that is flowing through the ecosystem I'm about to show you. So don't forget, regardless of the color of the arrow that I made it, all arrows are supposed to show the flow of energy that originated from the sun. And the boxes, they're supposed to represent the population of organisms. Here we just have the grasses. That's the organism we're showing here. But there's going to be some other organisms. And so this box is bigger than the other boxes I'm about to show you because grasses, or the producers in an ecosystem, will always have the highest population number. So don't forget, the boxes represent the population size and the arrows show the flow of energy that originated from the sun. So you can see here that some of the energy that the plants, the grasses, have absorbed is lost as heat. As the plants are using the sun's energy and they are breaking open those sugars to energize their body, they are actually releasing some of that energy stored in the sugar as heat. Some of the energy that was absorbed by the plants will then be passed on to some type of primary consumer, either an herbivore or an omnivore. Let's use this bison as an example. It will absorb that energy that was originally from the sun, went to the grasses, and now it's going into the bison, and they're going to use the sugars made by the plants to power their bodies. But that's not the end of the story as far as the energy flowing from the grasses. Where else does the energy flowing from the grasses go? Well, you can see how big this arrow was going in, so that amount of energy has to leave. And here we have some energy flowing out. So there is some energy left over. So where does it go? Well, it's going to go into the decomposers and the detrivores in an ecosystem when the grasses die. The decomposers and detrivore, will take in a lot of that energy that was originally from the sun. Decomposers and detrivores, here are some examples. We got mushrooms, bacteria, and we have a variety of invertebrates such as snails and pill bugs or roly-polies, millipedes, and there's a slug, a mite, springtail earthworm. These things will be able to live because even when the plant dies, some of those sugars are still available to be used as food. Some of the sun's energy is still in those sugars, and they can be used by the decomposers to power their body. But let's go back to the bison. Some of the sun's energy that it had gotten from the plant will be lost as heat as it moves around. One of the flaws in our metabolism is that we release heat. We are not 100% efficient with the sugars. Some of that energy from the sun that is in the sugars that we ate from the grasses, or that the bison ate from the grasses, is going to be lost as heat. Now, warm-blooded animals have taken advantage of this, and it allows us to live in very cold areas. But initially, it was a flaw that really nothing could be done about. We just lost heat whenever we would process sugars. We also lose heat as we just do our day-to-day activities, burning sugars, just to live, to walk around. Something you might notice here is that the box has gotten a lot smaller. Also, this arrow, look how much heat was lost by the plant. Look how big the plant's population box was. Compare that to the bison's, and it's gotten pretty small. Why don't you take a guess to why you think that is? Well, hopefully you've realized that since this is the amount of energy going into the next trophic level from the original amount of energy that went into the grasses, since this is all that is left to go to the next trophic level, since this amount was lost as heat and this large amount was given to the detrivores, this is only the amount of energy available to allow this population of bison to live. So their population is always going to be smaller than the grasses, and that's a general rule. The producers will always have a larger population than anything else in the ecosystem, since it is the grasses that everything is getting their energy from. The producers. Some of that energy from the bison will also, as it did with the grasses, when the bison dies, it will just be decomposed. When the body of the bison is available to be consumed by decomposers, they will free the energy from the body of the bison and use it to power themselves. But not only that, the decomposers and the detrivores will also be able to unlock the energy that was not used by the bison when it made poo and pee, its waste products. So a lot of the energy that originally went into the bison is going into the detrivores again. But if you look, some of that energy is actually going to go to the next trophic level. The predators of the bisons. Once again, either an omnivore or a carnivore this time. This bison population is going to be consumed by wolves. So let's say it's the only thing consuming bisons. This is more of a food chain. Well, this is a food chain. So hopefully an ecosystem would be more complex than this. But in this ecosystem, you just have grasses and bisons and wolves being accounted for. So of the energy that went into the bisons, some was lost as heat, some went to the decomposers, and only a sliver is left to go to the wolves. And you can see that the wolves' population is far smaller than the bisons, because the energy, all this energy that went into the bisons are not available for the next trophic level. Some was lost as heat and some was lost to the decomposers again. But assuming that the wolves are the top predator, or the apex predator, that means nothing will eat the wolves. There is no next trophic level. So where will the energy that was originally from the sun, went to the grasses, went to the bison, now it's in the wolves, where will that energy go? Well, once again, it will either go and get lost as heat to the atmosphere, the air around these animals, as they're moving around and processing the sugars, or the energy will go to the decomposers again. But the story doesn't end here. since even the energy in the decomposers will eventually be lost. And just to take a real quick second to look how large the population of decomposers are. Okay. They are very large in population because look at all the energy that goes into them. So although decomposers are kind of gross, I would even say that, they are smart because they will take advantage of food that is available to them and which nothing else will eat. But you can see here that the energy that went into them is lost as heat. Eventually all the energy will be lost. All the energy that was originally from the sun that entered the planet will either be lost to the atmosphere, and a large majority of that will eventually be lost back into outer space. So the energy came from outer space and then it left back into outer space. So it came and went. So looking at this chart, use your rationale. Would life continue on Earth's surface without the sun? Why or why not? Would life continue on Earth's surface without plants? Why or why not? And focus more on energy when you answer this. Well, hopefully you said that no, life could not exist without the sun since it is the source of energy on the surface of the earth. And no, life could not continue without plants since they are the special organisms that can actually harness the sun's energy and save that energy in sugar molecules. I mean, we can't do that. That's why we need to eat things. That's why we have lunch, dinner, breakfast, all that. We can't make our own food, but they can. Now this diagram looks very similar to the one you just saw, but this one is representing carbon from the other video I had made. And this is more or less how many of the atoms cycle through an environment, especially CHNOPS, if you remember. Carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. So matter, atoms, you can see here that it's not just lost outer space, it will actually be taken back in. So matter, atoms, molecules, these will be continually cycled through an environment. Never lost, always just transforming what they are. But that is very different compared to energy. Energy is, there's an entrance and an exit for energy. It is not recycled. It comes and hits the earth, and if it's absorbed, it's used the best to the ability of the organisms on the planet, and then, eventually, it is lost back to outer space. So I hope you enjoyed this video on energy. I know I have. And, till next time.